Hello everyone. Today I would like to talking about how to use the GraphPad one-way or two-way ANOVA for analyzing body weight or avoidance passive avoidance test. This is the outline I will talk today. Firstly, you need to install the GraphPad Prism and how to select the test. The second one we analyze the body and organ weight, and the last is we analyze the passive avoidance test. If you use the GraphPad, you can analyze a lot of um, data, for example, body or organ weight, passive avoidance test, or Morris Watermaid. So today we focus on the body weight and passive avoidance test. And here the link you can download this software, and it can give you free around 30 days with only use your email. So the first one I mentioned about significant difference. So I have two groups, each group around 8 people, and in the smoking group around the body weight around 62 kilogram, and in the non-smoking group the body weight average around 71 kilogram. So my question is, does smoker weight the same as non-smokers? So I make the two hypotheses. The first one is known hypothesis. In the average weight do not differ. It means that the body weight in smokers equal with body weight in non-smoker. It means that 62 may be equal with 71. It means that not significant difference. And another one I call alternative hypothesis. We call that the average weight between the groups is different. So in here it means that the body weight in the smoking groups maybe is lower than non-smoking groups. So how to select non-hypothesis or alternative hypothesis? In here we need to calculate the p-values. As you can see here, the p-value is calculated from the statistic test, for example, t-test, ANOVA or fructose test. And in here we if the p-value would use to reject the null hypothesis, it means that the body weight between smoker and non-smoker is equal. So if your p-value less than 5%, it means that the body weight is significant different in the smoker and non-smoker. Or you can say that the body weight in the smoker is lower rather than non-smoker. It means that you need to reject the null hypothesis and you accept the alternative hypothesis. And if the p-value more than 5%, it means that you accept the null hypothesis. It means that no significant difference between non-smoker and smoker. So next, talking about the distribution data before you selecting the test. Here we have two lists of the data, right? You can see here the median and the average, very important. The median, it means that the exact middle of the list of values. You can see here in here I have the list of data, and 6 is the middle of the list of data. And in here another list of data, I also found that the median around 4.5. So opposite for that, you can see here average is sum values divided by number of values. And you can see we have the list of data, and the average is around 5.7, a different with median, right? And here the average around 4.7. And you can see here this list, the median is maybe wider than this list. You can see 6 5.3 and 4.5 with 4.7. If the median is close to the average, you can draw the graph like the bell shape here. So let's look at detail about that. So I have I scale my from day 1 to day 26, and have the mean around 46.7 and median around 50.9. So if my median is higher than mean, it means data in negative direction, they call negative skew. Or if my mean maybe higher than median, if my data is positive direction, is a positive skew. So ideally, the mean and median equal, we call a normal distribution. And in here is that the data no skew, and it is very important to select the test. So now we go to how to select test, right? And you can see here, if I have two groups, group 1 and group 2, I have different mice, my 1 to my 6, and then here they call unpair because we have different mice. And here you can choose the t-test, or if you have the same mice, my 1, my 2, my 1, but we measure in different day, day 1, day 2, day 3, day 4, they call the same mice, and we have pair groups. And in here you, if your data have normal distribution, we call parametrics, we can use the pair t-test. But in case your data is skew, it means that mean different with median, we call non-parametrics. In the unpaired groups we use the Mann-Whitney, but in the pair group we use the Wilcoxon size rank test. Similar with that, if you have three groups, group 1, group 2, group 3, and we have different mice, in case your data is normal distribution, the called parametrics, we can use one-way ANOVA. And if your data is skew, mean different with median, you can use the crypto wallets. Similar with that, if you have the same mice but you measure different days, you can choose the pair test. For example, you choose the one-way repeat measure ANOVA, or you can, if your data is skew, you can use the fragment test. And after that, you can use the multiple comparison plot test. I will talk a little later. And here we need to compare how we different between one-way ANOVA and two-way ANOVA. One-way ANOVA, we talking about only focus one independent variable, and two-way ANOVA we focus on more than one independent variable. Let's look at the graph and easy to explain. You can see here, one-way ANOVA we only focus on body weight in different groups, and two-way ANOVA we focus on two variables. The first one is body weight, and the second one is date. We can know exactly which day the body change in between four groups. So in the one-way ANOVA, they recommend we use the Dunn's test for multi-groups comparison, and in the two-way ANOVA we use the Turkey test for multi-group comparison. So here I grow mice and I measure body weight from day 1 to day 26, and I have the organs. After that I dissect mice, I collect the organs. I have testes, brain, kidney, spleen, heart, liver, something like that. And after that I can draw a graph like that. For example, here I have the body weight of 6 mice from day 1 to 86, and after that I use one-way ANOVA to compare different body weight among four groups in here. And I also use the two-way ANOVA to compare different body weight among four groups from day 1 to 86. But the more important one, you need to write down the title right here. For example, comparison of body weight among mice, male mice treated with 1,2-diacylbenzene and donepezil plus DAB. So, and data was given by mean standard error of mean and 6 mice per group. And you need to explain the abbreviation. For example, control treated with saline, right? And DAB treated with my or DAB treated with donepezil. You need to explain your abbreviation here, and you need to explain the star here. For example, 1 star represent for people living than 5%, and 2 star the people live than 1%, and theta for the people live less than 0.1, compared with control. And you, which test you use? In here I use the crypto wallet test and đơn test for one-way ANOVA, and turkey test for two-way ANOVA for multiple group comparison. So now I will show you how to how to write, how to draw the figure like that. And here I will end, and I will show you my data. And here I make the data, right? I have around 6 mice, and I measure the body weight from day 1 to day 26. In here I will open the GraphPad. After you open the GraphPad, they will show you like that. So in here they said you need to select the table and graph, right? In here I choose the column, and I create. In here I will copy my data. I copy from my 1 to my 6, and I go back to the GraphPad. I copy, I'm sorry, copy here, copy, and I paste it. After that I click on the button here, and I choose the show row titles, and after that I copy the body weight from day 1 to day 26, and after that I paste it. So in here I have the data in the table, and now you go to the graphs here, you click the graphs, they will show you the default graph, right? So in here you can see that they said that they have the mice, the body weight from different mice, right? But here we don't know which days. So in here I need to change the graph. I click the change graph, I choose the groups, and in here I choose the summary data, and after that I choose the line here, and after that I click OK. So in here you can see now the graph show the body weight grams, from day 1 to 26, and you can see the trending of data, right? It means that from day 1 to day 6, the mice increase the body weight after you take care of them well. And here I will make edit the graph to make the graph more beautiful. The first one I choose the gram and orange to make the thickness of the axis maybe smaller. And in here I will my one here I will select different shape to make sure that we can easy to recognize them. In here I choose the not the shape, and I choose the color dots, and in here my tool here I choose the not the shape, and I select the another color like that. Let me see again. Here I will, yeah, I think maybe better. I don't know. In here, yes. And another one I choose the, maybe I choose the empty, and here I choose the here with with the blue one, and here I select with click here. So now you have around 6 mice, and you have body weight during day 1 to day 6, and here you can edit. If you click here, you can show the angle, right? You can see here. If I don't want to make it in like that, I will change the position of the title in here, and now you have the graph like that, right? And look at my graph here. You said that the body weight and different change from different days, and you can write the title, right? So now I want to show you how to make the two-way one-way ANOVA like that. And here you need to create the ANOVA, right? And I make the new table, and here I choose the groups. Because I have 6 mice in one group, I enter 1 2 3 4 5 6, and have a create. And in here I will copy my data. In here I will copy my whole data here. I copy my whole data body weight here, and I paste here. So in here I will write down my name. I double click. Let me see. Here control. Yeah, you can see here. You can double click here. Control DAB, and DAB plus données par jour, 50, and DAB plus données par jour 100 milligram per kilogram, right? After that, okay. So now they will show you the graph. As you can see here, they can make the graph easy, right? As I mentioned before, right? Because your data is so small, so I recommend you use the mean width SEM, right? Because you make the error bar is smaller, and after that you click OK. And now you can change the title. And here I change the title is body weight gram, and then here I delete the data here and the title here, and here I will change the color. Maybe here I change the color the green one. I change the color here is the maybe in the pink one, and I change color here is the blue one, and the last one I change the color is the purple one. Yeah, you can change the color every color you want. So in here I have my the graphs compare body weight different days and different in different days in different groups. So now how you know whether or not the body weight in the groups in different day is significant or not. Here we need to use the two-way analysis. You go to the new analysis, and here they will, after you click that one, and you need to choose the data, and here I choose the data 2 because data 2 is the data for make compare raw four groups. And after that I choose the group analysis, and here I choose two-way ANOVA. I click OK, and then from here I will choose the multiple comparison, and in here I choose the with each rows compare columns. And in here the option I will, as mentioned before, right, multiple comparison, you need to choose the Turkey test, right? After that I click OK, and now you go to the multiple comparison, and you see that on the day one, control with DAB significant different, control with DAB and Donny Brazil significant different, and control DAB with Donny Brazil one, that significant different. So in day one I will go back to the graph, and I make the uh, statistics compare between them, right? In here I will choose, here I select the thickness around 1.4, and in here I select the statistics around 3 star, right? In here I want to make the thickness of the frame and origin around 1.4. So now you have the graph like that, and after that you need to check again in day A, day 15, day 21, day 26, like that, and you can compare significant difference between the groups. In here they call two-way ANOVA. So now I want to make the graph for one-way ANOVA. In here you no need to do everything, you only click the new graph, and you select the data too, and here you choose the column, and on here you select the graphic individual values, and here I refer to choose the mean width SEM, and I click OK. So now I have the graph compare between two groups, but only focus on the body weight, only one variable. And here I also edit my graph. You can see here I choose the frame is 1.4. I choose the color here. I want to make around 1.4, and I fill with the pink one, green one, and here I select 1.4 with let me see, a little bit red, And here I will select with maybe the blue one, and in here I select with my wrap with maybe a little bit great one, and in here I have 4 graph. So now you need to compare the body weight different groups here. Here I choose the new analysis, and in here I select my data level 2 and hit we need to choose the one way, right? Because I need the one way. I choose one way ANOVA. I click OK. As I mentioned before, right? If your sample size too small and the mean and the median different, so in that my case, I know my data is skewed, so I choose the non-parameter test. If your data is normal distribution, mean equal with median, and you can choose the ANOVA. In here you choose the non-parameter test, and after that you choose the multiple comparison. You choose the compare the mean each column with each column. And the option here, as I mentioned before, right? One way ANOVA, you use the multiple comparison for use the done test, and after that click OK. And now you go to the multiple comparison. You said that the control and the DB they control groups have the body weight lower body weight compared with DAB. The p-value around 0.9. It means that you go back to the data here, and you can make the significant in here around 2, and you click in here, and choose here. So you finish how to align the body weight using one way, two way ANOVA. So go back to my lecture, and you can make the graph like that. And more important one, you need to make the title, right? You can see here comparison body weight among my treated with drug or another compounds, and data given with means minus or plus with standard error of mean, and the number my is 6 per group, right? And here you need to define the abbreviation here and define the star here, and with that you use similar with that you need to make align data with the organ weight. In here I make the organ weight with testis, brain, kidney, and I compare testis, brain, kidney with different groups, so you can did similar with the body weight. Now talking about passive avoidance, so I have the 2 room, bright room and dark room, and in the normal condition, so which room the mice will enter. As you know that the mice is nocturnal creatures, so that's why they will love dark rather than they love light. So in here my will go to the dark room rather than the bright room. So in the case we use electric shocking condition in their food, and which room the mice will enter. In here they use nature to make the passive avoidance test to evaluate learning memory in rodent models. And in here the mice will learn to avoid the shocking food in the previous step. So if they remember this room have the shocking, they will move to the bright room, even they love the dark room. So in here this is the room they will enter in the next time. And after it means that if the mice have the normal learning memory, it means that we spend time um, uh, longer in the bright room compared with dark room. So here I have the protocol to detect the passive avoidance, right? And at the now I only talking about the passive avoidance test in the prep tools passive avoidance. In the training day, you put the mice in the bright rooms, and you give them around 10 seconds for elimination. and after that the mind will go to the dark room because they love the dark room. So but in the dark room here you put the electric shock around 0.3 milliampere for 3 seconds, and after 24 hours you perform the test again. In here, if the mind they have the normal learning memory, they will remember yesterday I come here and I have electric shock, so now I need to stay here, I don't want to stay here. So if the mind they don't remember, they memory and learning impairment have impairment, they will go here. So that's why the time spending in here is less than compared with control one. So after you measure the time, latency time, you can have the data like that. For example, control group, LPS group, scopolamine XD or vitamin plus XD. In here you need to draw three figures like the same with body weight, right? The first time you need to draw the latency times in different miles in different days, right? And one way ANOVA only focus on latency time among four groups, and two way you consider about latency time in different tests among four groups. And please remember, around the title, you can see here I draw the title is DAB impaired cognitive function, why donepezil combat the cognitive impairment induced by DAB. You can see here, right? They explain a little bit the latency time. You can see here in the acquisition in the first day, right? You can see they will go directly to the dark room because they love the dark room, right? But the second day you can see the mice, they stay in the bright room until the Thursday. uh, Similar with that, you can see here in the DAB, the toxic drugs. So they can call, the mind cannot remember. So when we put the mind in the bright rooms, they will go directly to the dark room. So that's why the time in the bright room is lower compared with other groups. But if you treat it with donepezil the drug for Alzheimer treatment, and they remember, and some might they will go to the dark room, but average one the transfer latency in the donepezil group is higher than the DAB groups. And in here you can see that the DAB reduce the latency times compared with other groups, and we found a lot of significant difference between donepezil treated group compared with DAB groups. In here we can explain that DAB impair cognitive function, whereas donepezil combat the cognitive impairment, right? And then here my data was given for was measured by passive foreign test, and all data given by means minus or plus with standard error of the mean and sigma per group. And similar way, we need to explain the abbreviation, and you need to explain the star here, and you need to explain which test you use. So in here I will show you how to make the graph like that, right? And look at your data again here. In here you go to the first row, you can see passive run test data here, right? And here I will copy my data here, from here, and I go to the GraphPad. I make the new data table. Here I choose the column, and I click create my column. Here I choose click the bottom here, and I choose the table format, show the rows, and I paste it. Because here I want to make around sigma, I copy the title from here, I paste here. I have my 1 to my 6, and I have data from different days: acquisition, retention 1, first, second, third. And now you go back to the graph, and you say that you can see here they make the default one, right? But similar by the way you go to the groups and select summary data and select the lines, and after that you click OK. So here you can see you can right here transfer latency time second. I want to delete here. I want to delete a title, and I want to select maybe origin here with the 1/4, and I select to recognize the my easy with different color, with different shape. Here for example like that, with the red one, and similar you can change every color you want. And here I also want to change the angle. Right here I choose the angle, and here I choose around 30. I click OK. You can see they will change a little bit. Next one, you need to make the one way or two way. Right, similar for that you need to create your data table, and I choose the groups. And here, because I have sigma in one group, I create six. After that I click OK, and I copy my data from 1 to 6 here. After that I paste in my data here. Because I already know my data here, I will copy the title from this table too, and here I paste here. Right, and now I have data in my table. Similar with that, the first one, we need to make the two-way ANOVA. Right, easy. Here they make for you already, you no need to change, but you only change for the mean width SEM, right? Because your data small, if you choose the SD, you can see the error bar too large, so I want to choose the ESM. And here I will make the title E transfer. I will change the color. I change the color with the green one. Here I will change color with the yellow one. The blue one. Here choose color with maybe gray one. And here, and after that you have your data, right? So, and I also change my frame here. Let me see. Click the frame here, and you can select 1/4. So in here you need to compare the transfer latency times different day, right? And you go to the analysis, select because in here you need to select the data for, and here I have the, because I want to make the two-way ANOVA, I choose the two-way ANOVA. I click OK, and here I only go to the multiple comparison. I choose the with row compare column, and click OK. So in here you will go to the multiple comparison, and you can see that in the day one, on the third retention test, you can see control DAB 2 star, DAB 50 2 star, and DAB 100 3 star. So I go to the fifth one here. I make the graph like that. Make the graph like that, 2 star. Make the thickness, and here I have around 2 star. 2 star from DAB, and you can select here with 3 stars like that. Yeah, so you can do similar with the second time second retention test, or the third retention test, by checking, you can see here first retention, second and third, similar with that. And here is the two-way, right? So now I want to make the one way, and easy, right? You can go to the new graph, and you choose the data number 4, and you choose here the column, and you select the second one, and you choose the mean width SEM, and click OK. And here they show you the graph like that, right? I only make the retention times. I select the frame with or ring width, beautiful one. I change the color. mm, mm, with the blue, the purple one. I change here with maybe with the a little bit green one here with uh, purple, and the last one, and maybe I refer to choose maybe the that one. So now you have the color like that, right? You can select color and everything you want. So now this is one way ANOVA. You need to go to new analysis and you choose one way ANOVA with the data number 4, and you click OK. In here, because your data is the sample size too small and the mean and median different, so that's why you need to use the non-parameter test, and after that you select the multiple comparison, and you select the compare each column and every column and click OK. So now select the multiple comparison. You can see that compare between 4 groups, no significant difference were found. So in here, even no significant, you also need to make the uh, statistics in your graph like that. Yeah, we make the no significant. uh, you can make like that, it's easy, right? It means that no significant between the groups, and after you write, you can copy and you can paste in your paper or your Word or your PPT like that. And remember that you need to describe your data, right? For example, as I mentioned before. So thank you for your listening. I hope you enjoy my video.